ratios. We've talked about ratios are whether it's part to whole, part to part. We've talked about equivalent ratios by increasing that ratio or decreasing it. And today we get kind of into the more meaty part of ratios, which is comparing ratios. So when we are looking at comparing ratios, apparently the dogs are going crazy at the moment, we want to maybe compare recipes, or we're comparing two things, and in this case I'm going to show you a juice recipe. So you're making juice at home and you want to know whether you should use recipe A or recipe B because you want a more juicy flavor. You hate watered down juice. So in recipe A, we have 2 cans of juice to 3 cans of water. And in recipe B, we have 3 cans of juice to 4 cans of water. And I want to know which one's going to give me a stronger juice flavor. Well, if I have juice, juice, water, water, water. Over here, I have juice, juice, juice to water, 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 water. Now, just by looking at this, we can't tell which one is going to give us a better juice flavor. So what we have to do is we have to pair them up. So I have a can of juice and a can of water. I have a second can of juice and a can of water. And I now have 1 can of water left, which means half the water will go to here and half the water will go to the second section. So right now I have a little bit of a formula for my juice here. So I know that juice and water is going to give me the exact same flavor, half and half. I now have a container of juice and I know what the flavor will be. Over here, I'm going to do the same thing. I have juice, water. I have juice, water. I have juice, water. And now I have 1 part of the water left. And when we're using fractions, we're going to kind of estimate here. But it's about 1/3 of a cup of water is added to each one. Sorry, I didn't mean to cross that out. It's supposed to be underneath. So now all I have to do is, I know juice and water are going to give me the exact same flavor. But now I look at this fraction section. And in recipe A, I have half a cup of water for each little part of my recipe. And in recipe B, I have 1/3 of a cup of water. Well, I know that a half is more water than 1/3. So if I had half a cup of water and 1/3 a cup of water and I added juice into it, the juice is going to be more flavorful in less water. So recipe B gives me a more flavorful juice by a very little bit, but that is still the math we need to do. Half a cup of water is more than 1/3 of a cup of water. If we put the same amount of juice in it, 1/3 will taste more juicy. All right, we're going to look at another example here. And in the Google Doc that I gave you, that goes along with this lesson, I showed you the math for this hockey card, basketball card, using a very similar format to what I just did here. So I'm going to take it and show you a little bit differently in terms of fractions. So I want to go out and buy a set of sports cards. I collect sports cards. And for some reason, the manufacturer is only selling them in combinations of hockey and basketball cards. So if I choose box A, I have a ratio of 4 to 3. 4 hockey cards for every 3 basketball cards. Box B has a ratio of 3 to 2. So 3 hockey cards for every 2 basketball. Now, as a collector, I'm only really interested in the hockey cards. So I really love hockey. The basketball cards don't mean much to me. So if I want to spend or buy a certain number of boxes and I want to get the most hockey cards for my money, what I need to do is, if I have 4 over 3 as a fraction and 3 over 2 as a fraction, remember, whenever we're comparing fractions, we need a common denominator. So I'm going to look at the lowest common multiple. My multiples of 3 are 3, 6, 9, 12, 15. Again, a great place where your multiplication chart's going to come in handy. And my multiples of 2 are 2, 4, 6, 8, 10. Well, right away I notice that my lowest common multiple is 6. So I'm going to say something over 6 compared to something over 6. What did I do to 3 to make it a 6? I multiplied it by 2. Whatever I do to the bottom, I do to the top. 4 times 2 is 8. What did I do to 2 to make it a 6? I multiplied it by 3. 3 times 3 is 9. And now that I have that common denominator, I can look at whether I get more hockey or basketball cards. Remember, this is the basketball cards and this is the hockey cards. So right away I notice if I bought 2 boxes, I'm going to end up with, or looking at a common denominator, sorry, comparing number of hockey cards to number of basketball cards. For every 6 basketball cards in box A, I get 8 hockey cards. For every 6 basketball cards in box B, I get 9 hockey cards. So I like hockey. I'm going to obviously choose the bigger number. So box B is going to be my choice. It's going to give me more hockey cards for my money. There's one more way to do equivalent fractions, or comparing ratios and showing equivalency. And it actually is kind of my favorite method. It makes the most sense. Why? Because, you know, I like everything organized. And I find that a table really well organizes my thinking. So now I'm going to talk about, I have a farm. And in plot 1 of my farm, I want to put in beehives, because beehives are going to help with cross-pollination. It's going to help my plants stay better. So if I have, in plot 1, I have 3 beehives for every 4 acres of pears. And in plot 2, I have 5 beehives for every 6 acres of grapes. What I'm going to do is draw a table. Plot 1, beehives, 2 acres. Not really mattering here what I'm growing, it's just the number of acres. Plot 2 is beehives, again to acres, or you can put the fruit in, doesn't matter. It keeps your brain organized. So for every 3 beehives, I have 4 acres of pears. If I have 6 beehives, I have 8. If I have 9 beehives, and all I'm doing here is 3 times 2, 3 times 3, I have 9, so 4 times 3 is 12, and I'm going to go one more. 3 times 4 is 12, 4 times 4 is 16. I'm going to look at my comparison plot over here. I have 5 to 6. Times 2, I get 10 to 12. 3 is 15 to 18. 4 is 20 to 24. And now, again, I look at that common denominator. If I want to use the most beehives, I'm going to use this comparison here. And notice, as soon as my acreage equals out, 12 becomes my common denominator. So for my pears, I have 9 beehives for every 12 acres. And for my grapes, I have 10 beehives for every 12 acres. So I'm using more beehives per acre in my grapes. Table organizes it really nicely. You just have to remember you're looking for the common element, like the common denominator. All right, that's it for comparing ratios. Tomorrow's just going to be a review of all the ratios we've done. And on Monday, we're going to look at rates, unit rates. If I want to buy something on sale, or I want to buy a box of something, am I better to buy a smaller box that's cheaper or a bigger box that's more expensive? We're going to look at finding out to see what kind of deal is the best for us, because obviously we want the most for our money. All right, everybody, you have an awesome weekend. I will see you on Monday. Remember, tomorrow's just a review.